Hello, everyone, and welcome to another great episode of Hive Live. I'm your host, Alex Neddy. Hopefully, you've been following all of our great, approachable cybersecurity content on social media. But if you haven't, you can find us on all the major channels as at Hive Systems. So make sure to go and give us a follow. Joining me today is my co host and the legend behind the Hive Systems 2022 password table, Corey Neske. Hey, Corey.
Hello, Alex.
So unless you've been offline for the past month, then you've seen our famous password table, and it was updated for 2022. It's been featured on news sites like CNBC, Dark Reading, and even the top of the front page on Reddit. It is a great conversation starter about cybersecurity best practices, but there's a lot of layers behind its colorful facade. So, what was our methodology? What assumptions did we make? And what can you do to better protect yourself online? Well, today we're talking about all of that and more while answering your questions live. So, let's get into it. Corey, obviously, we first developed this table back in 2022, leveraging some data from a site, How Secure Is My Password, where you can go and punch in a password, and it'll give you an idea of how long a hacker or how long it would take a hacker to brute force that password. We decided it's 2022, and things have changed pretty significantly since then. We've obviously made some big updates to the table. Talk us through how we approached it in terms of kind of the overall methodology.
Yeah, the first thing we wanted to do is just make it current. So what hardware is available today to do what was assumed back in 2018 or 2020. And it wasn't clear what hardware or assumptions they were using when they, How Secure Is My Password provided their great page and service. So we wanted to make our own and also share those details because there was also a lot of doubt, I think, looking at the discussions about the previous password table, like, well, what is it based on? What hashing is it? What's the hardware? So we thought, let's put all that in the open and let people talk about it and get some good feedback and then make it better each time we update it. And I think the reason behind it is that passwords are, for some reasons, still leaned on heavily for security and privacy, and they continue to be part of large-scale data breaches. And even with things like MFA and the lockouts and all of that, oftentimes when those controls, multi-factor authentication, when they fail, you're falling back to these passwords again. So on a rough day for a company, they're coming back to these, and then they, sometimes people neglect to make stronger passwords with MFA, and if they don't have the system fail closed, this can happen. But also, and perhaps more importantly, the passwords are obnoxious, and there's no love and hate with passwords. It's just hate. We have tiny screens on our phones now. Swipe autocomplete puts in spaces automatically when we're trying to type in our passwords that might not have spaces. At least for me, the fingerprint scanners are not reliable. So it's only hate. So we wanted to make sure that suffering counted with a security efficient password, because we've seen like XKCD talk about that great comic where they're talking about if you have just a bunch of words, a passphrase, that it can be a lot more secure and a lot easier to handle. And if you have a short password and it is super complex and cryptic, it's not actually that secure. So it's like we're wasting that inconvenience. We should really figure out like, okay, what counts?
I think that's a good point, right? I think we are past the point of passwords and they're outliving what they were supposed to do at this point. It's not the best way forward, but we don't really have much else. And that's really the point of where we are with this table, is saying, hey, since it's all we've got to make better decisions about it. There's a lot of stuff definitely coming down the pipe from a lot of bigger companies like Microsoft with things like Windows Hello and push passwords, which I think are going to start to help to overcome the password need, but we're not quite there, and it's definitely not widely adopted right now. So that's exactly the impetus for us creating this table, is to have better discussions about passwords, help people make better educated decisions, but maybe more importantly, understand kind of that why, for why a lot of companies, maybe their employers or even the websites they use online, require or have some of these requirements around passwords. Corey, let's dive into the methodology a little bit. Obviously, we've shared out the table, and it's been shared high and wide. But there is also a methodology write-up on our website. If you go to www.hivesystems.io/password, you'll see that full write-up. We talk about our methodology behind it and some of the things we're going to discuss today.
That's right. I'll put that up on screen here. Yeah, so do check out that post because you're going to get more detail, specific numbers on and a list of assumptions in there. A lot of the stuff we saw people commenting on, and a lot of great feedback in Reddit and other forums about, well, wait a minute, did you assume that they only had one graphics card? Did they use cloud? What was the encryption algorithm? How many iterations did you assume? What about cost of that technology? All of that is, or most of that is in that blog post. And the more questions you ask and clarifications you ask, the more we can update it, make sure it's comprehensive. So definitely check that out for more detail and some things we might miss as we're talking through these.
And yeah, only 12 minutes, definitely something you can sit down and peruse through while enjoying your morning coffee. We answer a lot of your burning questions, including around if your passwords have already been stolen or not. And we'll talk about some of that stuff here shortly.
Yeah, and I don't want to give the impression that it is such a deep dive that it's boring for most people. I think we bounced it toward the let's just keep it simple and not simple, but clear, concise, so that anybody can understand it if they read through it and gain a better intuition about what this password thing is, why the IT people obsess about it, why the standards keep asking about it, even though it seems so old school. So first thing we got to settle here is that a lot of people thought that, well, some people thought that this was about guessing a person's password on a phone or a website. So you might have a screen like this, where it's enter your username and password, and you can imagine when we say cracking passwords, we mean we're going to type in, the person's pet's name or birth date and whatever, password 123, and that's brute forcing. And that is brute forcing a password. But as a lot of people pointed out, there's a lot of websites block that activity. As you know, you do 3 tries and you're like, I'm going to get locked out, and you're really hardcore. You have a phone that self-destructs when you type into any incorrect passwords. So just to clarify, that's not what we are testing here. We're testing stealing the database that sits behind the login screens. So those tables of hashed passwords. And sometimes we'll say, or you'll see in headlines, a password database or password table or encrypted credentials. And what they're really referring to is this concept of hashing, which is to store the secret on the server side behind that website in a way that the password's not just sitting there in plain text. So you just have this list of people's passwords. And obviously that would be bad because the engineers who manage those websites or the people that host the websites could just go in there, take a look, and now they have all your passwords. So among other reasons, what we do is we hash the password instead. And that involves taking the input, which is shown here. You type in your password when you create it for the first time. The server's taking that, or it's done on your computer on your side, and it's running a calculation against it. So to make a very simple example of a hashing algorithm, you can imagine just multiplying each character in the password by the number 2 or something. And then what you get on the other end is this thing that's not your password, but it's going to be the same if somebody else does that calculation. So there are problems with that. Like, you don't want it to be reversible so that you can now divide by 2 and all of the password is revealed. You just want to know that there's provenance. Like, this is what it says it is. I don't need to see it. I just need to know that it's authentic, that this password that this person types in is the one that they typed in when they created the password. So early on, there were algorithms, or there were hashing algorithms like MD4, MD5. You might have heard those around. And those are more sophisticated calculation than just multiplication that will take your password and spit out a hash digest, which is shown here on the right under the magnifying glass, which is always going to be the same length by design. So even if you can go to a antivirus website like VirusTotal, And you can put in a whole file and say, put a malware sample in there, or a Word document, or a program, or the recording of this video. And it will always spit out a hash digest of the same number of characters. And the probability that that will match another thing, like a picture of a cat that has been sent through this algorithm, is very low. So what you can do is make sure that when I hash this password, when Alex hashes this password, you get the same number, but I don't need to know what the password is, only that it was, the algorithm confirmed that this is the right piece of information. So when you create a password on a website, it's getting sent through that hashing algorithm, and then the output is being stored in the back end, like this table, this simple illustration is showing. And then when you log in the future, it's checking against that to be like, okay, they put in this case, CNESKI is the username. Now, do the hash that password? Okay, now we have this string of characters. Does it match the hash that's next to CNESKI in our password database?
And I think you've definitely touched on the key piece. A lot of folks online were wondering, yeah, I forget my password often. I can only enter it 2 or 3 times before I get locked out of my account. How is a hacker going to try this over, as our table shows, a couple quadrillion or thousands of years? And that's exactly the answer. If that database of all these hashes was unsecured and someone could steal it, they no longer have that lockout in place. So as a result, they can try it over and over and over in perpetuity against that database of those hashes. So that is definitely one of the key assumptions here, is that that database has been stolen. But time and time again, we see, especially with websites and other companies, those databases do get stolen, and then hackers have the opportunity to start to work on those passwords. And that's where this password table starts to come into play. Corey, tell us more about some of the cracking of the hashes and how that starts to work, especially based on the speed and power of the devices.
Yeah, so it's a preferred method to take those hash databases, password databases, because you can just keep trying to break in, and no alarms are going to go off because you have it offline on your computer. And the way that we do that, well, I digress. Before we go to that topic, what I want to say is address another thing that people are pointing out, that there exists these pre-hashed sets of passwords that people typically use. So disclaimer here is that if you're going to use a password that has been part of a data breach before, somebody already stole the database, they cracked the passwords, they put them up on the internet, and then there's headlines about this password breach. If you use a password that was in one of those, you might have gotten a notification via email saying, we got, your password was part of a data breach, change your password. So if you reuse that password, none of what we're about to talk about applies. It will be cracked probably right away, because if you're an attacker, you're not going to waste time doing what we're about to talk about. You're just going to try all the typical stuff first. Let's try that 1,000 most common passwords right off the bat, and it's going to take us a couple minutes. Or if they're targeting you specifically, they're just going to look up your username on the internet and say, what passwords has this person used before? Or what are their hobbies? And narrow down a set of words that matches your personality. If your local sports team, maybe your last name, all that stuff can factor into like narrowing the scope of what your password might be, so it becomes much faster to guess. So they're going to do that first. If all else fails, they'll move on to something like this. And so this table is just to represent if it's part of a breach, if it's a top common, a password 123 password, it's going to get, they're not going to bother cracking they're just going to break into your account probably. And if they do try to crack it, it's going to be very quick.
Talk to us a little bit too. Obviously, reusing known breached passwords is a key piece of this puzzle. One of the ways we like to think about this is when those databases get stolen, oftentimes those hackers will use those known passwords to start to kind of carve out chunks. So using those known hashes, they can quickly start to say, all right, I can guess and get the plain text versions of these passwords, the ones that I can actually use to log into websites. Maybe I can get 50% of them with these known passwords, what's called a dictionary attack. Then there's other known words that people use from things called rainbow tables. So maybe now I have 75% of the database all available to me to be able to use, to sell, to log into websites, which maybe that leaves about 25% of the database of unknown passwords, which I think gets us to the next part here, which is depending on how those passwords have been stored and hashed can start to impact how quickly that hacker can crack and brute force those passwords.
Right. So one place that you can find those previously breached passwords is haveibenpwned.com. And it's just, I think it's Troy Hunt who's been just maintaining this database of like, what are all the big breaches, which of them have been cracked, and what hash algorithms they were discovered using to store those passwords. And so you can see there's some, this is definitely not all of them. There are hundreds of these, unfortunately, over the years, but you can see that there's big names on this list that have had these breaches of this password hash database, and then people go at cracking them. And the bigger the website, the more funded you'll probably be to crack the passwords. And those hashing algorithms that we were talking about show up here on the right. So SHA-1, Bcrypt, MD5. MD5 was the one we were talking about earlier, and is the one that we used in the 2020 table, as well as this year's, and we'll explain why. Then there's also some qualifiers like salting a password, which is basically throwing in another bit of information before you do that hashing calculation, like throwing a random word at the end, or the name of your company, or hopefully something more random than that, to the end of your password, and then hashing it so that it changes the hash digest more, which makes it harder to guess the way that we'll describe. And
Corey, why do you think some companies do this better than others? Obviously, generally recommend stronger hashing algorithms and salting, or if you're using a hashing algorithm with built-in salting, that's ideal. Why do you think companies fall short on that? Even Domino's, as of 2019, still using MD5. That's pretty bad for how many folks use and leverage their website.
The first thing, the optimistic reason would be that these different algorithms are computationally expensive for your server, and for the client. So for us on our computers, that hashing is happening either on our computer, in our web browser in the background, or it's happening on the server side. And so if you pick a really strong hashing algorithm, you have to, it's more, you can imagine your fan going off on your computer. Like, it just takes more to process to handle that. And so you wouldn't want to, like, you could visit a website and you log in and your computer starts steaming, and this your fan goes off because it's taking so much compute. But the reality is there are definitely algorithms that will do that if they chose to. Thankfully they don't. So it's a balance. They have to consider the user experience and also the lag. Like, makes it a stressor on your computer, but it also makes it take longer. So who loves to sit there and wait to be logged in? That is one reason. So things like MD5 and SHA-1, I don't believe they were originally built to be slow. They were just built to hash. They weren't like these modern encryption algorithms that were built by design to be heavy burden to crack and to calculate, which ends up being not a big deal on a per user basis. People have to wait a split second more than usual, but it's a big deal when you're the attacker and you have to crack this huge database of passwords and you have to go through all of them. And now it's Bcrypt or it's PPK or whatever, and it's just more expensive, whether it's in the cloud or at your computer onto your desk. But also, I think a lot of it's just technical debt. Your authentication mechanism is not exciting. You have MD5 hashing of your passwords because you started your business in 1992 or whatever, and you're 1994, and you just still have it, and you think about all the other stuff about security that's more exciting. But it's one of those things that it rocks the foundation.
I think that's a good point, because it really comes back to that idea of within the world of IT, often it's just about it working and not necessarily working securely, especially in this case where we're told to hash passwords. Technically, all of these companies were hashing the password. It's just that some of them are doing it better than others. And so that takes us to a place where for a lot of these companies, maybe they don't want to focus on applying resources to changing the hashing algorithm. It's a lot of computational work. It's deeply technical in its approach, and you'd rather focus on updating your pizza tracker for Domino's and making that work better and have a better user experience than putting time and money at updating that hashing algorithm. So I think like you said, for a lot of these companies, it's just not a priority, and considering it's still technically working, then that's enough for a lot of them. That's not an accusation against them or saying that their companies are bad at doing this, but I think for a lot of companies, it's not the first thing that comes to mind when they're thinking about their website and the security around it.
Yeah, for sure. And so to talk about the actual cracking of these passwords, people discovered that calculating hashes or doing these kind of simple calculations, think of things you can do on your calculator. It's much faster to do that kind of calculation using a GPU, which originally was made to process graphics on your computer, to do 3D design, to play video games mostly now. But then more recently, crypto mining. So like if you have a simple calculation requirement where you don't care about what the previous calculation was, so you can have parallel processing with GPU, which means you can calculate a whole bunch of passwords at the same time. You don't need to crack one at a time because they're not related to each other. There's no relationship between this random person's password and this other person's, so you can do this parallel processing, which GPUs happen to be great at. So what we did is we assumed the perspective of a hacker who got one of these password databases. And again, it's a password digest database. It's not really their password stored in there. But the kind of thing you hear about in the headlines that we're showing here, you can doom scroll down through the haven't been pwned site and just see all these websites. And that, again, is like stealing a safe that contains the keys to a safety deposit box from a bank, because maybe that safe is like right up front at the front of the bank and they don't really protect it as much because it's just a bunch of keys. But if we can manage to open that safe by cracking them, we can raid the safety deposit boxes. And that's kind of what's happening here. So what our password table represents is how long it takes hackers in that situation to reverse engineer the passwords based on the hash. Let's see. I don't know if this next slide is the right one, but I'll show it. So where we started was there was this assumption of the best consumer graphics card in 2020 that it looks like was used. And we wanted to similarly find like, what is the graphics card everybody wants today? And once we looked at those, if anybody who shops for a gaming graphics card or looks at supercomputer stats or whatever, they're going to see flops and megaflops and gigaflops, and whatever, to describe the incredible computational power. And so they advertise them as that, but we know that things get watered down once you consider the other parts of the computer. So that number is not, even though it's called calculations per second, that is advertised in your graphics card, you're not actually going to get that many calculations per second for the task that you have, such as something very specific like password cracking. Things are going to degrade as you deal with like, well, how good is the motherboard? How much RAM do they have? How much cache does the graphics card have? Like, think of all the other pieces on your graphics card other than that shiny chip that is where the heart of the GPU is. All these other things come into play. And so we wanted to get as close to the ground truth as reasonable by gathering hashing performance data. Unfortunately, there is this software out there called Hashcat, which anybody in security community is very familiar with. It's commonly used in coursework even as part of training. And it's a utility that it does multiple things, but one of the components of Hashcat is simply generating these hash digests. So you take a list like this set of passwords. So these are just somewhat randomly generated passwords that you could use for testing the speed at which you're able to translate all these into those hashes.
And we should definitely make a note. Please don't use any of these passwords.
Yes. I was going to say that. Yeah. So these are not strong passwords anymore because I just put them on the internet. So don't use them. If you see the password here, your password here, you should apply to the lottery because they're randomly generated. So, apply to the lottery, buy a ticket, I mean. So the nice thing about Hashcat is that it's going to try, actually I have a picture. I'm going to jump ahead inside, so it'll be confusing. So this is Hashcat and their icon. And if you go on their website, you can see what kind of algorithms they use. You can see MD5 and SHA-1, some of the things we talked about. They're going to say, feed in that list of passwords. We'll use this hashing algorithm or methodology on each of them, and we'll tell you how fast your computer was able to do it. And that is what a lot of people do. And thankfully, they also post on the Hashcat forums their computer's performance. Like, I just got this new sweet graphics card. I want to see how fast it does all of these things. So they post it online. They post it on the forums, on GitHub, YouTube videos about them. And some people will get to use a supercomputer or a data center, and they'll try it on theirs and show you the performance statistics. So that is what we use, because we thought that is closer to the ground truth than trying to like calculate some theoretical. If you take the calculations per second that the advertiser does and how many, we didn't want to get into that. So let's see. This tool became a lot more popular recently because people care about crypto mining, and crypto works similarly in what they're trying to do. The calculations are, the kind of calculation that they're doing is the same. So a lot of them probably looks to Hashcat benchmarks to see what's the best GPU or rig or combination of graphics cards for me to mine crypto, to do the calculations required. And so this tool has new popularity, and it also has caused a big GPU shortage, but also a big demand in the market to make more graphics cards and stronger ones. So some people just go in here just to say, like, how quickly could my gaming PC or my Xbox or my Nvidia cloud GPU that I have at work, how quickly could it hash these random passwords? You might be wondering why would we hash these random passwords? Because the hash is not, when you hash a password, it's not reversible. So what ends up happening is you can't just take the hash, like I said earlier, and divide it by 2, and then you get the password at the other end. It's a one-way street. And so the way that they solve this, and when we say cracking passwords, what we really mean is we're taking that really long list of passwords such as these and hashing them, and then seeing if we can match that with one of the ones in the hash database. So it's like we can't decrypt the hash, but we can hash all the different combinations of words and characters that we can think of, or that the computer can generate, really, hash them, and then look and see if any of them match, and they will, and they do. And that's how they end up cracking. Now, that ends up being actually a very large task because the options are on a computer, as you know, seems ever increasing. Like emojis are now a part of this. But what we did for our tables, we assumed this character space, meaning you're using either lowercase, uppercase, numbers, symbols, and then also these advanced symbols that I don't have examples of in here. But if you're typing, think of other languages that have different alphabet, different fonts, these special symbols that you see programmers use or statisticians use. There's these things that aren't in your keyboard, but somehow people magically make them. You can include those in your password in a lot of cases, and those end up becoming part of the pool of possibilities. And if you randomly generate a password, a few of those might get thrown in. So what we did is we said, assuming that we have all those characters, tell your computer to generate all combinations of those characters together, which is a massive data set. And then go through, hash them all with MD5, and now compare. Do we have any matches from that data set that just came out in a data breach?
That's a good point too. And one of the top recommendations that we're starting to make around developing passwords, if you can use alternate options, or the site that you're registering your password on accepts other characters or font related things. So emojis, even if you use like a Apple or Android device, sometimes you can hold on a key and get other options, right? An umlaut or something else that can give you a much stronger password because it's not from kind of the standard set of dictionary attacks that a lot of hackers are using. that's a huge advantage for you as a consumer with minimal extra effort on your part to use that as part of your password.
Yeah, and all these numbers that we have on our password tables, if you were to cut out these special symbols that most people probably don't use, it's all cracked even faster. And it's probably a reasonable assumption, and this is something we've considered for the next set of password tables. But we did have a lot of people that specifically piped in and says, I use these random Russian character or Cyrillic alphabet characters, and okay, but I don't think a lot of people know how. But it's a balance. This is just another. I think this is from yesterday. I just took a screenshot of like what are the latest big password breaches. And as you can see, there's a few things in here. You probably got an email from a couple of these saying, "Hey, we changed your password, or please come in and change it as soon as possible."
Yeah, and with the 11 billion accounts there that have been stolen, I'm sure some of them are duplicative across people who have maybe used and reused the same password. So that's not necessarily 11 billion people across the earth, but it's probably a pretty good number of them. So likely you have been impacted in some form or fashion at some point.
Yeah. Just to show, like, if you do end up using Hashcat Utility, you just run it on your computer, try it, you're going to get something that looks like this. This one is actually run on a device that has 4 GPU. So it ends up giving you the individual performance of each one and then giving you a aggregate at the end of how fast, how many giga hashes per second you can hash. So how quickly can we take that huge data set of characters and all their combinations and make all of the possible, make the hash table of all of them that we can then diff, or we can compare against to find the cracked password. And this is just the general format of, this is just some random, one of the outputs. And it shows the difference. Each section is for a different hash. And then as you go further down, it'll include things like salts, and then it'll include things like iterations and how which hashing implementation that you're using. Again, it's on Hashcat. So to get back to the colorful stuff, this is our original table. It's showing MD5 here. And let's see. Yeah, so this was actually probably about 2019 standards of a good graphics card. And the nice thing about it is that it was very balanced in terms of color, but unfortunately, things have changed. So we have upped it to I guess this is kind of fading, but this has been the most popular graphics card, 3090 from Nvidia. Instead, trying to hash those. So if we could, if you could just get one of these and assume that this is a hacker who's at it's their night job. They just have this gaming PC and I want to crack passwords. So it's pretty low budget. It's probably fairly common. This is what you get. And this is how quickly that they can generate all those hashes, do the comparison, find out which combination of characters was your password.
And that's a pretty big jump too. And this is just, in one graphics card, in a few years here. From the original table there, you can see that bottom right number was 7 quadrillion years, which is an unfathomable number, drops to 4 quadrillion years, which is still a gigantic number, but that's a huge reduction in a short amount of time. We're calling this the purple wave as it starts to slide down as computing technology has increased here. Obviously, we've been talking a lot about kind of graphics card for or use at home. But one thing we had to acknowledge in all of this, Corey, was the use of the cloud and the rise in prevalence of quick cloud computing and the ability to get access to lots of GPUs all at the same time through providers like Amazon.
Yeah, it's so easy now. I mean, so now you have, back in the day, it was like you have hackers with a gaming PC, maybe a few of them. Then it became like nation states with really fancy hardware. So what we used as our threat communities were, okay, hacker with a gaming PC, a hacker with money who uses cloud GPU, which is becoming incredibly easy now. In fact, you get a bunch of free time with a lot of these things just to try as a trial. So it might cost you nothing for some of the hashes. And then we had the hacker with money who uses other people's cloud GPU, consensually or otherwise, because there are services where you can rent out your GPU. It's a little complicated, but people do it. And right now, at least it seems lucrative because of crypto having robbed the market of graphics cards. So there's lots of options depending on where you are in the world, what resources you have or don't have, if you have money, if you don't. So we didn't know which one would be best, which situation is best to represent. So we did all of them, or we did all of them across the most common hashing algorithms.
Well, and right, we started here with MD5, which, as we noted, is one of the ones that's fairly insecure. Let's talk a little bit about Bcrypt. Obviously, that's a more secure algorithm, so that may change some of the math here.
Yeah, so if we went back to 2019, around there, 2020, with that graphics card, and then you stole a data set that was Bcrypt, which happened in that list, you saw there were a few places that use Bcrypt, which is great because then it's just a lump of data that you can't do anything with. As you can see, there's barely any purple in here. There's no, when we say instantly, it just means less than a second. And so you buy yourself a lot, at least with that graphics card at that time. But we wanted to, this was interesting to see, but we wanted to factor in, well, people have nicer graphics cards now. So we said, okay, Bcrypt and I should add that a lot of people think Bcrypt is one of the most secure options right now for a hashing algorithm, but again, it's expensive. So some people prefer not to use it. And there was some debate about it that I probably shouldn't get into because of time, but about, yeah, I won't get into it because I'm going to confuse everybody. But main reason people don't seem to use it is it is expensive on either your end. It's going to slow down your login process, or it's going to increase especially in the cloud, the money you need to pay for cycles of to handle people's passwords, which is massive when you think about how many people some of these companies have to handle passwords for. So it didn't really help all that much in terms of color, but in terms of number, like your 8-character password up with upper and lowercase 92 years to 18 years. And of course, all this is just kind of a snapshot to give you a reference point, because obviously every day that goes by, we're getting better hardware. So that's why these numbers are all rounded, because we don't want to give the impression of like extreme precision, it's like this is exactly how long it's going to take. So just consider the fact that this is the snapshot of this point in time, and every day this is becoming slightly faster. The rate is going slightly faster.
And yeah, even for consumer at-home hardware like this, Nvidia's already announced their new line of graphics cards that's supposed to be some factor faster than even this one. So we look forward to updating this table here when that starts to come out and hit the market.
Yeah, and one of the things you can do that we've been able to do, and that people have rented out, is cloud GPU. So there are people that have rented 8, I think it's EC2, Nvidia A100 GPUs. So you're renting GPUs in the Amazon data center and then sending the encryption job, the hashing job to that, and it's doing all the work for you. You're getting, and then you get the data back.
Well, definitely something we should note too right now is with the rise and advent of cryptocurrency mining, a lot of those at-home options, those NVIDIA graphics cards, are selling for hundreds, if not thousands of dollars on secondhand markets because they can't be found from stores at retail. So that takes you to an interesting place where maybe going and finding an option on the cloud is better. Corey, what did you find for the price per hour for this cost?
It wasn't much. I don't have that ready right now. I would look at did you have it?
I want to say it was somewhere around like $32 or something an hour. So, if you're faced with a computationally less robust graphics card at home for thousands of dollars, if you can find one, or get an on-demand cloud option, be able to work on passwords for $32 an hour and actually have way more power than the at-home option, if I'm a hacker, I know what I'm signing up to do.
Yeah, and if you don't want to go with big corporate, they have sites that, again, as people rent out their hardware, it's very close to the same hardware in terms of GPU, but it's only like $5 an hour because it's some random person with their computer. And I cannot say how secure these things are, and they could be sting operations, so who knows? So, but it's incredible how much cheaper you can get this sort of thing done. So again, MD5, so if we assume that people are using the hashing algorithm, which might be fair to assume because a lot of the websites are still using it. And the key thing Alex had pointed out to me, because I was like, I thought we should maybe use Bcrypt, and then it was pointed out that it's computationally expensive. But then when we said, Alex pointed out that there's a lot of websites that are still using MD5 and people reuse their passwords a lot. So they're kind of like, we end up being socially as secure as our most insecure websites, the Dominoes or whatever. I mean, they probably have increased their security by now, but the reality is they're going to crack these passwords there, and they're going to know your password at that point. So now they can just try that password on all the other websites, just do that first, or a derivative of it, add a different number at the end. So yeah, I mean, this is the kind of the easiest way to crack at this point is just rent a bunch of 8 GPU and send the job.
What does this table then look like for Bcrypt?
Yeah, so this one, if we did assume that they are using Bcrypt, which thankfully there's some people that are, and it slows things down significantly, but you're still looking at 2 years for the 8 characters of upper and lowercase, which again, this is best case. It assumes that the password's randomly generated, and people most of the time aren't. So this is like, if you're lucky, this is how long it'll take. So that's pretty scary, especially as people are saying, don't change your passwords anymore on a yearly basis, so that this little timer of 2 years doesn't reset in a lot of cases unless you're forcing people to rotate their password. What do we have back here? NIST had recommended formally hashing implementation, PBK, DF2, and then some sort of hashing algorithm to use with it. In this case, we assume SHA-256 because we saw that this combination of things was used by a lot of password management websites, major password managers. So if you subscribe to one of those that generates passwords for you or stores them, they appear to all encrypt them with this. And so let's just assume the ultimate worst case scenario, your password manager gets hacked and they steal that database of passwords. This is if the person has a just gamer's graphics card, how long it would take them to crack. But it assumes things like there's this thing, this is 999 iterations. This is just a number that when you're hashing those passwords on the server side usually, or when you're hashing those passwords, you can increase this number to make it even stronger, to make it even more difficult to reverse engineer like we've been talking about. And you have to increase it to a point that it doesn't cause login times to be terribly slow. And so it ends up being a balance. So people are kind of forced to pick a somewhat lower number. So we didn't get too much into that because it can vary so much that we didn't end up going with that for our table. And it is not, unfortunately, not as common as it should be. So it seemed unfair to assume people are using, password vault quality encryption. But if you are, awesome. Yeah, so in the end, we ended up going with, let's assume, either you have a local rig, which having an 8 GPU array, like the A100s, surprisingly common because of crypto. You can rent it on major cloud providers. You can rent it somebody else's computer, timeshare sort of thing. And so that's what we ended up picking. I talked about our reasons earlier for MD5. But again, it's a kind of a reference point, and it is the result of our balancing, like what is actually happening in reality based on what we're seeing in data breaches.
I think that's the key point here. Obviously, we looked at all these different computational options, both at home and in the cloud. We also looked at all the hashing algorithms that exist, and ultimately, it came down to a factor to say what is the easiest to get a hold of in terms of computing power. And like we talked about with the global shortage of GPUs and their overall expense on the secondhand market, it's much easier to go stand up an AWS instance real quick with much more power for much cheaper. So that's kind of part one of the equation, was to say that's probably the best option for someone who's looking to brute force passwords. The second, then, like Corey mentioned, is that idea that unfortunately we are beholden to the lowest common denominator. So for a lot of sites, both startups and larger companies that continue to leverage old hashing algorithms like MD5, since we as consumers don't know what those websites are using, it's up to us to make better password choices. So as a result, this table you see here is the official table that we have published based on that AWS GPU compute power and using MD5. Next year, when we update this table, we'll take a look at overall computing power, see how things have changed from that side, and if we should be moving to a different algorithm. If maybe the adoption of Bcrypt ends up being more prevalent, then that's probably where we'll start to focus this table and pick it as the official table that we publish out. But if we continue to see breaches that are still using MD5, this table will live on. And unfortunately, in about a year's time, I'm going to guess that that red and purple section starts to slip down just a little bit more. So for everyone at home, this continues to be something critical to find better passwords to protect your accounts. Obviously, the biggest one we continue to preach as well, leveraging things like password managers that can help you create secure passwords and help you save individual unique passwords between sites so you don't have to remember all of them. But of course, we always recommend enabling multi-factor authentication or two-factor authentication, something that comes through right as a text message or maybe a code on your phone. That helps stop hackers in their tracks so that even if they do get a hold of your password, they don't have that second factor, and that can keep them locked out. So remember to enable that on any and all websites that you use, everything from social media to your bank accounts to even places where you store your photos like Google Cloud or Apple's iCloud. Corey, any other takeaways from today?
No, just keep the feedback coming on our website and the Reddit thread, and all the great comments. Like, what about if, in some situation, like what about how much power it takes? That might be interesting to see. What about if we assume Moore's law? The computation, can we kind of forecast what this table is going to look like ahead of time? These are all great ideas, so please do keep them coming.
That was a good one. Yeah, we saw a little bit about some folks starting to talk about the advent of quantum computing. There's a working theory and probably pretty close to reality that as computers get faster and we start to understand the ideas of quantum computing, passwords are going to be obsolete very quickly. So this whole table will probably look like that all purple version that we showed earlier. That's when I think we in the industry, both in cybersecurity and the world of IT, are going to have to find a better way forward and to get prepared for that inevitable future. Awesome. Corey, this was wonderful. Obviously, this table is available for download on our website at www.hivesystems.io/password. Go check it out. Take a look at our methodology. Leave a comment if you have any thoughts about it. You can obviously find us here on YouTube, but also on our website there, and let us know what you think. If you're looking to have a better discussion with your family or even just your company, make sure you grab a copy of this password table and share it out. It is a great conversation starter. It is not the end-all be-all to security, but it will help you understand some of the ways that you can balance risk and why it's so important to have strong passwords. That's all the time we have today. We hope that you ultimately found our discussion about our 2022 password table enjoyable. Stay tuned for next year when we look to update that table again. Like we talked about, we'll look at evaluating how powerful GPUs are, what Amazon the cloud is offering, what at-home companies like Nvidia are offering for their graphics cards. We'll even look again at how password hashing algorithms have changed. And hopefully you'll see a new and updated version of the table, and we'll see what it looks like. We look forward to that. As always, our experts here at Hive Systems can help make your cybersecurity journey approachable and always having better discussions about how to manage your passwords and authentication for your organization. So please reach out at www.hivesystems.io/contact us. Before we go, make sure to subscribe to our YouTube page at www.hivesystems.io/Hive Live. Next month, we're going to be talking about something that's become an increasingly popular problem for organizations. It's responding to cybersecurity risk questionnaires. This is when you might be working with a larger company and they have a bunch of questions about how your company is managing cybersecurity. How you answer those questions could impact whether or not you win that work or that contract and are able to work with that client, or if you're left out in the cold. So is there a right and wrong way to answer those questions? And does it mean you need to spend a bunch of money to get up to speed on cybersecurity just to win that contract? Well, join us next month and make sure that you subscribe again to our page there at www.hivesystems.io/Hive Live. Until next time, remember, when it comes to cybersecurity, you need to act and not react. Thank you.
Thank you.